All right, looking at 613 homework number 34. According to the State Department of Finance, California's population was 33 million in 98, 99, 2000. Find the percent increase from 98 to 99. So to do percent increase, I would take the amount of increase, so subtract 33,765 minus 33,218, and I would divide it by how much was there. I believe that looks like this. The increase was 0.547 million divided by, it used to be 33.218 million, for an increase of 1.647%. From 99 to 2000, the increase was 0.571, and the population was 33.765 million, for an increase of 1.691%. The percent increase was not linear, so we can suggest population exponential growth. So let's make our model y equals, we began at 33.218 million with an increase of 1647 to the x. And if we make this years since 1998, we can say x minus 1998. Then we can put right in 2020 minus 1998, get our exponent of 22. So we are thinking our population in 2020 would be 47,580,000,000 people. All right, looking at D. In the year 2000, California had 34.336 million people times the rate of 169-ish. We can go approximately an increase of, I got 580,000 people. Let's call it roughly that. Explain why the increase is proportional to the population, but because it's a percent, that would be why it would be proportional to the population. It's a multiplier. 1.01 is your constant. All right, let's look at 35 and do some integration. A is pretty straightforward. 6 to the x minus 3 secant tangent. Can break it up, can look at it individually. The integral of 6 to the x is 6 to the x divided by the natural log of 6. The integral of 3 secant tangent is just 3 secant, and then always with the plus c for our indefinite integral. Let's look at b. We've got a definite integral, pi 0 to 2. We go 2x squared minus x squared squared. Let's go ahead and simplify inside here. 4x squared minus x to the 4th. Integrate that. We'll go to 4x cubed over 3 minus x to the 5th over 5. We want to go from 0 to 2. If I put in the 0, I'm going to get 0. So let's put in the 2. 4 times 2 cubed over 3 minus 2 to the 5th over 5. Don't lose that pi in front. Common denominator. 64 pi over 12. All right. In C, we're going to have to factor. I'm going to go ahead right away. 3x. We got to guess that the x plus 5 is going to be a factor. If not, we're not going to do this. So if that's x plus 5, this is going to be 3x minus 2. Double check. 3x squared plus 15x minus 2x. There we go. Good to go. Go away. 1 to 4 of 3x minus 2 dx. Go ahead. 3x squared over 2 minus 2x from 1 to 4. Put the 4 in. 3 times 16 over 2 minus 2 times 4. Minus, put the 1 in. 3 halves minus 2. What do we get? 24 minus 8 minus 1.5 minus 2. Let's call it 16.5 area under the curve. All right, last one. 6m to the negative 4 thirds dm. We can derive with respect to anything, really. dx, dt, dm. Add 1 to negative 4 thirds, 6m to the negative 1 third, divided by negative 1 third. I would probably go ahead and multiply by the negative 3. Negative 18m to the negative 1 third, plus c. Could we also simplify it a little further? Negative 18 over the cube root of m plus c, as long as we know that those are equal. All right, sketch a function in 36. I'm going to use yellow again when we describe some of our derivative stuff. And then let's go with red when we're talking about the function. The limit as x goes to negative infinity is infinity, so it's going to go up here somewhere. And the last part, the limit as x goes to infinity, is 5, so we've got some kind of a horizontal asymptote here. Then I'm going to go to yellow and talk about the other two. The limit as x goes to 0 from the right of the derivative. So the derivative at 0 from the right is negative 1. 0 from the left is negative 1. 0 from the right is 1. That's its derivative. Then I'm going to choose a dark color for the actual function. We need to have a sharp point there because the derivative from both sides do not agree. So therefore, the derivative at the point does not exist. Okay, our favorite flag problem. What is it going to look like? Oops, that's not it. What is it going to look like if we rotate this guy around the x-axis? I am seeing half a sphere, and a cylinder. Let's call it 1 sphere plus 1 cylinder. Area for us, volume for a sphere, 4 thirds pi r cubed plus volume of a cylinder, pi r squared h. The radius of our sphere was 6, 4 thirds pi 6 cubed. Radius for our cylinder was 3. Our height was also 3, I can see. Pi 3 squared 3. Adding those guys up, all whole numbers, 315 pi's. Volume of our flag. All right, We just simplified a few of these in 612. Y equals 2 log 2 of x. When these match, y equals x. Our derivative is 1. Nice. All right. Y equals tan of 10 to the x. Derivative of tan is secant squared of 10 to the x times the chain rule of the derivative of 10 to the x, which will be 10 to the x times 1 over the natural log of 10. Not 1 over the natural log of 10, times the natural log of 10. C, y equals cosine t times tan t. If we make this cosine over 1 times sine over cosine, again, these go away. Y equals sine t. Derivative of sine is just cosine. D, y equals tan of e to the x. Derivative of tan secant squared of e to the x times the derivative of e to the x is e to the x times the natural log of e, but that's 1. All right, what do we got? One more. Y equals 2 to the cosine of w cubed. The derivative of 2 to something is the natural log of 2 times 2 to the something times our double chain times the derivative of cosine is negative sine w cubed times the derivative of w cubed, 3w squared. So all of this would be multiplied. Natural log 2 to the cosine w cubed negative sine w cubed 3w squared. Chapter 6, homework 3, done.